Hello everyone. Today in this video we're going to discuss some of the criterias which will show us that when two triangles can be said to be congruent or not. So those criterias will be going through. So first criteria of congruency is the side angle side congruence rule. So what does this side angle side or SAS in short congruence rule states? So let us see. Now according to this congruence rule, if there are two triangles, then we can say both the triangles are congruent if two sides and the included angle of one of the triangle is equal to the two sides and the included angle of the other triangle. Now let us make it clear with the help of a diagram. So as you can see here, there are two triangles ABC and PQR. Now these two triangles will be congruent according to this rule only when two sides, any two sides we can take, and one included angle in between those two sides. If they are all equal, then we can say that both the triangles are congruent. Now in this figure, in these two triangles, which things are equal? In triangle ABC and triangle PQR, we have AB equals to PQ. Now as you can see in the figure, there is a line that is marked here, single line, and here it is double line. So you can see here this side AB is equal to side PQ. Okay, then angle B, this angle and this angle, angle Q, they are also equal, and side BC and side QR are also equal. So you can see here these two sides are equal, and this angle which is included in between these two sides, this angle you can see this is in between these two sides. Clear? So in that case these two triangles can be said to be congruent. Now let me make it clear that what about this single line and double line. So these markings are given to indicate the corresponding parts. So here you can see generally it is used for indicating the side. So this single line indicates that this side is equal to this corresponding side, and this double line will indicate that this side is equal to this corresponding side. Sometimes triple lines are also used. Say in this case, if I use here a triple line on side AC or PQ, then it will indicate that AC is equal to PR. Clear? So these are just used to indicate the corresponding parts. So this was all about the side angle side or the SAS congruence rule. Now moving on to our next congruence rule, that is called the angle side angle, or in short ASA congruence rule. So what does this angle side angle congruence rule states? Let us see. According to this congruence rule, two triangles are congruent if two angles and one included side is equal to the two angles and the included side of the other triangle. So let us see with the help of a diagram. So as you can see here in the diagram, there are two triangles, triangle ABC and triangle DEF. Now these two triangles are congruent because the angle B is equal to angle angle B is equal to angle E. Then the side BC is equal to side EF, and angle C is equal to angle F. So you can see here there are two angles and one side included in between these two angles. And if this criteria is fulfilled, that two angles and one included side of one triangle is equal to the two angles and the included side of the other triangle are equal, then both the triangles are congruent. Now here we are going to prove that how this thing is correct. So let us see. So in the proof, first of all, we'll write the given part. So in the given part, as you can see in the figure, there are two triangles, triangle ABC and triangle DEF, And in these triangles, what we are given is that angle B is equal to angle E, side BC is equal to EF, and angle C is equal to angle F. Clear? Now one more thing I want to say is that while proving any congruence rule, say this one, angle side angle, whatever is given to us, okay, whatever the statement says, that thing comes in the given part. So as the statement says that two angles are equal and one included side, so here also you can see these two angles are equal and one included side is taken in the given part. And while proving it, while we prove that this triangle is congruent to this triangle, we will be using some other congruence rule to prove that. We will not be using this congruence rule because we have to prove this congruence rule. And for proving the congruence rule, we use the help of other congruence rule. Clear? So as we go forward with this congruence rule, you will understand. So let us see how to prove it. So what we need to prove here? We need to prove that triangle ABC is congruent to triangle DEF. This is our main task to do. So let us prove it. Now for proving it, we will consider three cases. Clear? And these three cases will prove that this congruence rule satisfies. So let us see what are the three cases. Case 1, if AB is equal to DE. Now this is assumed. Okay, we have just assumed it that AB, side AB is equal to DE. We don't know actually. We have just assumed it. It is just like a consideration, you can say. So we have considered let AB equals to DE. So you can see here the side AB and DE we have considered to be equal. Then what comes next? Yes, so in the diagram you can see this side AB and DE are equal. So we have marked it by 2 dash. You can see here 2 lines are used. So it will indicate that this side is equal to this side. Clear? Now in triangle ABC and triangle DEF, now we are going to find out the congruency of these two triangles. We are going to find out which corresponding parts are equal in both the triangles. So if you see carefully in triangle ABC and triangle DEF, which parts are congruent, or sorry, which parts are equal? We can consider AB equals to DE. Already we have assumed it that AB equals to DE. Then we can say angle B is equal to angle E. If you see carefully in the diagram, angle B is equal to angle E. Already it is given to us. Then side BC is equal to side EF. This is also given to us. So which congruence rule we are using here? As you can see, this is the side, this is the angle, and this is the side. So by side angle side congruence rule, or SAS in short, we can say that both these triangles are congruent. So this case is satisfied. Now let us see the next case, case number 2. So case 2 says that let AB be greater than DE. Now this time we have taken side AB to be greater than side DE. So in that case the diagram also will change a little bit. So here we can see we have done an extra construction. So let me write those construction. So what construction we have done here? We have taken a point P on AB such that PB is equal to DE. Now clearly, if someone clearly observes the diagram, so it is very obvious that PB cannot be equal to DE. Okay, so that is the thing we will contradict in this case. That is our main task here. We have to contradict that PB is not equal to DE. In fact, AB is equal to DE. That we have to prove. And if we show that AB equals to DE, then our job is done. We can show that this triangle is congruent to this triangle, just like we have shown in case number 1. But for the time being, we have assumed that this PB is equal to DE by construction. So let us prove it then. Now let us focus on this small triangle PBC and triangle DEF. Now in these two triangles, which are the what is called the corresponding parts? So if you see carefully these two triangles, then we can say that PB equals to DE. Already we have assumed it in the construction part that PB equals to DE. Then similar to the earlier case, that angle B is equal to angle E. Now this is also well known because it is given to us. Then side BC is equal to side EF. This is also given to us. So again, by side angle side congruency, we can say that triangle PBC is congruent to triangle DEF. But is this our main task? No. Our main task is to show that triangle ABC is congruent to triangle DEF. So let us proceed. Now, after showing that triangle PBC is congruent to triangle DEF, we can write that angle PCB is equal to angle DFE by CPCT. Now, if you remember correctly, that CPCT stands for corresponding parts of congruent triangles. Whenever two triangles are congruent, then obviously, or you can say automatically, all the corresponding sides and the corresponding angles, they become equal. So here also, since triangle PBC is congruent to triangle DEF, so obviously all the corresponding angles as well as all the corresponding sides, they become automatically equal by CPCT. This rule, CPCT rule. So here also triangle, in these two triangles, you can see this angle PCB will be equal to angle DFE. But we already know that angle ACB is equal to angle DFE. This is given to us. Clear? So what can we conclude from these two equations? We can conclude that angle ACB has to be equal to angle PCB. So if you look here carefully, angle ACB has to be equal to angle PCB. But is it possible? No, definitely not. This will contradict. This is possible only when there is one condition upon which these two angles can be equal. That is, only when P will coincide with A. So that point P has to coincide with point A, then only these two angles can be equal. And if it coincides, then is there any existence of point P? No, there is no existence of point P then. So then we can easily say that side AB is equal to side DE. Now, our things have become simpler. It has become similar to case 1. So, by case 1 we can say that triangle ABC is congruent to triangle DEF by SAS congruency. Clear? Now let us move on to the third case. The third case says that let us consider side AB less than side DE. So here also an extra construction will be done. That is, this point M we have taken on triangle DEF on side DE. So let us write that construction. So we have taken a point M on DE such that AB is equal to ME. So AB is now equal to ME. Now this is also obviously not possible. From the figure itself we can understand, but we have to contradict this fact and show that yes, this is not possible. So let us proceed. So if we consider now the triangle ABC and triangle MEF, then which parts are equal, or which corresponding parts are equal? First of all, you can write AB equals to ME. It is assumed. Then similar to the earlier case, angle B is equal to angle E given, and BC is equal to EF. That is also given. So again, by SAS congruency, we can say that triangle ABC is congruent to triangle MEF. But is this our main task? No. Again, here also our main task is to show that triangle ABC is congruent to triangle DEF. So similar to case 2, here also, since both these triangles are congruent, triangle ABC and triangle MEF, so their corresponding parts will also be equal. That is, angle ACB is equal to angle MFE. But again, angle ACB is equal to angle DFE. Already we got earlier also. So what can we conclude from these two equations? Yes, we can conclude that angle MFE will be equal to angle DFE. But is it possible? Yes, it is possible only when there is one single condition again. Only when point M coincides with point D. So again here the point M existence ends here, because if it coincides, that means there is no point M. Point M has become point D. So from there we can get that AB is equal to DE. So again, by case 1 we can say that both these triangles are congruent by SAS congruency. Clear? Now moving on to our third congruency rule, that is the angle side angle side congruence rule. So angle side is also written as AAS. So this, what is now angle side congruence rule? Let us see. Now two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. Now this is somewhat similar to angle side angle. Only thing is that in angle side angle the side was included in between the two angles, but here the side is not included in between the two triangles. It is there, but it is not included in between the two triangles. So let me show you the figure. So here you can see ABC and DEF are two triangles where angle B equals to angle E, angle C equals to angle F, and side AC is equal to side DF. Now here you can see this side AC and DF are not in between these two triangles, not in between these two angles. If it was in between these two angles, then it would have been angle side angle congruence rule, but since it is not, so it is under the angle side congruence rule. So let us prove this also. So first of all we'll write what is given to us. So already I have mentioned just now that ABC and DEF are two triangles in which angle B equals to angle E, angle C equals to angle F, and side AC equals to side DF. Now next we have to prove now that triangle ABC is congruent to triangle DEF. So how to do that? It's quite simple. Now we have learned about the angle sum property of a triangle, that the sum of the three angles of a triangle is equal to 180 degrees. So this property we'll use in triangle ABC. So then we can write angle A plus angle B plus angle C is equal to 180 degree. We'll mark it as equation 1. The same criteria we'll be using in triangle DEF. And there also if we use the same property, we will get angle D plus angle E plus angle F is equal to 180 degree, and we'll mark it as equation 2. Now if we compare equation 1 and equation 2, then we can see that the right hand sides are equal. So we will now just compare the left hand sides. So if we compare the left hand sides, our equation becomes like this. Angle A plus angle B plus angle C is equal to angle D plus angle E plus angle F. Now we can do some modification here. What you can do is that in place of angle B we can write angle E, in place of angle C we can write angle F, since we know that angle B is equal to angle E and angle C is equal to angle F. So our equation is modified. Now what we can do next, after we got this equation, next what we can do is that since on both left hand side and right hand side the angles E and angle F are common, so we can remove it. Clear? We can just substitute it, or we can just subtract it out, and what we will be left with is angle A is equal to angle D. So that will be our equation 3. Clear? So now we can apply the congruence rule in the triangle ABC and triangle DEF. So if we apply the congruence rule in triangle ABC and triangle DEF, then which are the corresponding parts that are equal? So first of all comes angle A is equal to angle D, just now we got from equation 3. Then comes AC equals to DF, already given to us, and then comes angle C is equal to angle F, that is also given to us. So both these triangles are now congruent by the ASA congruence rule. So as you can see here, this side AC and side DF are included in between these two angles. So that's why we have used the angle side angle congruence rule. And in that way, we can prove that both these triangles are congruent. Now, an interesting fact I hope you all have observed or you all have noticed it, that while proving any congruence rule, we are taking the help of other congruence rule, and whatever is given in the statement, that thing is written in the given section or in the given part of the proof. So whatever the statement says, that is written in the given part, and then while proving the statement, we are taking the help of the other congruence rule. So in this way we can prove the other congruence rule that we'll be discussing. Two more congruence rules are there. That is the AAS congruence rule, SSS, which is also called as side, and then there is the RHS congruence rule, which we'll be discussing in our upcoming videos. So I hope you all have understood today's video on the different congruence rules. So this congruence rule will be, we can use it or we can apply it to solve different kinds of geometrical problems based on triangles, and we can show that two triangles are congruent by using these congruence rules. So that's it then for today in this video. Thank you and have a nice day.